So we're going to do another optimization example problem. So this one's with a poster, and it's telling you it wants to get the largest printed area. So remember, like when you print a page, like I've just drawn like on a computer or like on a printer from a computer, you get those, you can only print on a certain part of the page, not the whole thing. So it wants to maximize the printed area of the poster. So the total area of the poster is 180. So I'm going to define the length and width of my poster as x and y. So then my area of the total poster is xy, which they have also said is 180 inches squared. Now I know that they have 1-inch margins. So from the edge of the page to the printed area, so that inner rectangle is the printed area, is 1 inch. At the bottom is 1 inch as well, and then at the top is 2 inches. So that inner rectangle is the printed area. So that's where the printer can print on. So it wants the dimensions that give the largest printed area. So I need the equation of the area of the printed area. So that's the equation I'm going to want to take the max of. So the area of the printed, so that length is, so that blue rectangle, that's my printed area. And the width of that printed area is going to be x minus the margins, so x minus 2. The length of the printed area is going to be y minus the margins, which are 2 and 1, so 3. So then your area of the printed portion is x minus 2 times y minus 3. And now my problem again is that I have the two variables on the one side, so I'm going to take that first equation. And I'm going to solve for y, so I get 180 over x equals y. I'm going to plug that into the area of the printed portion equation. So now I get the quantity x minus 2 times the quantity 180 over x minus 3. Okay, so remember, this is what I'm trying to maximize. So this is the equation I'm going to need to take the derivative of. I'm first going to multiply it all out to make it easier for myself. So I get 180 minus 3x minus 360 over x plus 6. So I'm just going to simplify again before I take the derivative. So a of p equals 186 minus 3x minus 360, and again I'm going to write it as x to the negative 1 so that I can take the derivative more easily. So the derivative of the area of the printed portion is negative 3 plus 360, x to the negative 2. So again, I'm going to have to find my critical point, so I'm going to have to set that equation equal to 0. So negative 3 is going to be equal to, or negative 3 plus 360 over x squared is going to be equal to 0. And now I'm going to move over the 360 over x squared. Okay, and then I'm going to multiply both sides by x squared. I'm going to divide by 3 on both sides, which is 12. Which is 12. And then I'm going to take the square root. So I get the square root of 12. Again, I don't need to simplify. Okay, this is inches. But again, I have to look at what my original problem was asking for. My original problem was asking for the dimensions that will give the largest printed area. So I do need the y dimension as well. I have the x. And now I need the y, and the y dimension was that equation 180 over x. So my y dimension is 180 over root 12. So now I know my dimensions are going to be root 12 by 180 over root 12. I'm sorry, I root x again. I'll fix that in a moment. But now it doesn't ask for this, but I just want to be clear. So if they wanted, actually, if they were asking for the largest printed area that resulted in, so they were asking for the dimensions here, but if they wanted the largest printed area, you would have to use that printed area equation, and you would just plug in the dimensions you got. But you do have to make sure, what is the question asking for? Is it asking for the dimensions, or is it asking for that largest area that you can get? Okay. Right. And again, you can simplify this and give yourself some decimals. It is in inches squared. Your dimensions would just be in inches.